All right. So let's see. Couple of tests. Hello, hello, hello. All right. Perfect. Share screen. Okay, welcome. So I hope that you can all see well. If not, please come closer, even though this is a big screen. Sometimes it's better to just get a little bit closer to it. So welcome. I am Manuel Gonzalez Canche. I am an associate professor at the University of Pennsylvania, and I'm very excited about the opportunity of offering this workshop. Can you all hear me well? Yeah, good, thanks. So as a little bit of background, this is the 4th time that I have been granted the opportunity based on peer review to offer professional development workshops at AERA. Just a little bit of context, not by all means, not to brag, but to show that this is actually applicable. The 2 flavors of workshops that I have offered are based on mixed methods research. So the first one, I offered it in Toronto, and these 2 participants attended the workshop. So that was very refreshing for me to know that after the workshop, we continue the conversation, and eventually they got the paper published at the Journal of Mixed Methods Research, which is the top journal on mixed methods research, as the name may say. So this is the type of analysis that I am very much interested in pursuing. I have to disclose that I'm mostly a quantitative researcher, but I'm applying these quantitative tools, data science tools, machine learning tools to hopefully ease the analytic process of textual data, qualitative data, and overall, as we will see throughout the presentation, I am very much interested in opening the opportunity to take advantage of data science tools without the need to program in or code. That doesn't mean that you don't have to learn how to code. It means that the barrier is removed by offering these standalone software applications. And more importantly, if you know how to code, you can expand upon what I am offering today. Everything is open source, free to access, and I will show you how to actually access the source code so that you can actually expand upon it if you are interested in doing so. Yeah, this mostly is based on R. There is some Python libraries that are called for visualization purposes, but I would say for LACOID, latent code identification, we have about 99% of the code is R. Yeah. Cool. Perfect. Yes, I will go there. Thank you so much. One more thing, because there are some participants who couldn't make it, I offer the option of recording my screen, so none of you will be recorded. It's just what I'm going to be writing on my screen and my voice mostly. We will distribute the recording as well in case you want to revisit after the workshop. All right, so let's start with our plan of work for today. So first of all, I want to acknowledge where I am currently located, in Philadelphia, the ancestral lands of Dene Lenape people. I am myself, I'm not from this country. You may have noticed by my accent, I am from the southeast of Mexico, and I'm proud indigenous. My mom is 100% Mayan. She's featured right there. And I am about 50% Mayan, so to speak. So in terms of a little bit of background, we're going to enter the handout and et cetera, et cetera. I graduated in 2012 from the University of Arizona with some concentrations in methods. That is why I am very much interested in continuing to applying those methods, hopefully to strengthen the possibilities of helping particularly at-risk students or underrepresented students. My agenda is to hopefully provide tools that are cost-free and open source so that we can continue building together. I am very much interested in software development. That's something that for many years I stopped using. I minored in software development in college back in Mexico. And basically a little bit connecting to the previous conversation, because of the professional development workshop was successful conceptually. I continue to work on offering these tools. However, the R code aspect of those workshops were a complete disaster. Like, people were very much interested in doing the analysis, getting the outputs, the visualizations. However, the coding part was a true, very almost unbearable challenge to surpass. So that's why I decided to find ways and means to package those codes so that it is user-friendly and it is click and point, or point and click, I don't know how you call it, that you don't need to spend any effort programming. You could, but you don't need to. All right. So the workshop plan, we're going to have about roughly 5 sessions. We're going to have time. I have this design time to apply what we're going to be talking about today. And particularly, if you don't have, I sent an email about a week ago, probably not many of you received it. In that email, I said that you were welcome to bring your documents for the analysis. But even if you don't have those documents, I'm also going to be providing access to a data set so that you can practice the whole analytic process in your computers. So we're going to start with the rationale, a little bit of the interface and outputs. This is going to be an iterative process. It's going to be, we're going to be talking about some of the same aspects throughout the presentation to keep building, hopefully. And then we're going to have a brief introduction to the main analytic engine, which in this case is latent Dirichlet allocation, machine learning, and some Gibbs sampling. We're going to mention what is the rationale of the text decomposition, of the topic identification, the importance of discard the X number of first random allocations, because they are actually random, in order to start learning what would be the most optimal distribution of this text. So it's not going to be we're not going to go into proofs. I have spent several weeks trying to translate all those equations with hopefully straightforward examples as to what is the rationale, what is the composition, what are the matrices that are being formed. In full transparency, you don't need to know those aspects to be able to use the technique. I hope that the conversation that we're going to have is going to help us better understand what is happening in the black box of the software. So that is the intention of the second section. Then we're going to talk about data structures, and we're going to see some applications. Very importantly, every single text input that we upload to the software is going to be classified. That means that it will be very important for us as analysts to decide what do we want to classify. What is the input that we want to classify? And the example that we're going to be looking at is based on 2 interviewer interactions, interviewer-interviewee interactions, where we're going to see that the voice of the interviewer, if we don't remove it, will be classified as part of the analytic process. So we have to find a common ground, a compromise, to be able to retain what we actually want to be classified. So we're going to show examples about that. That's what I mean by voices retained. Then we're going to have the possibility of, as part of the analytic process, as part of uploading the data, we're going to have the possibility of hypothesis testing, where we're going to see whether certain groups of individuals for a characteristic or the intersection of a set of characteristics that we may be interested are more likely to be associated with certain topics or certain codes than others. And that will be achieved simply by changing the name of our input documents. So you don't have to actually do anything. It will be a very simple test. It's at the end of the day, it's going to be a chi-square test of association. Nonetheless, it's another tool for us as researchers to understand what is going on in the multitude of data that we have at our disposal. All right, and then we're going to talk about text decomposition and aggregation bias. The text decomposition aspect will be quite important. Typically, when we are dealing with any form of machine learning, a text classification that is unsupervised, as the one that we're going to be looking at today, what happens is that the entirety of a document that we upload is going to be classified as a topic. And it is very, very difficult to believe that entire documents that can be 100-page long, that can be 30, that can be 2 pages long, belong to a single document, to a single topic, sorry, to a single topic. Rather, instead of assuming that one topic is good enough to capture the heterogeneity of code distributions within documents, we're going to first decompose those texts. And LACOID pays a lot of attention to the process of text decomposition by sentences, trying to mirror the line-by-line coding that we follow in qualitative research, and or by paragraphs, so that if our 30-page document has 1,000 paragraphs, I don't know if that is realistic or not, then we're going to have 1,000 text inputs from that document that will be then classified. If our 30-page document has 50,000 sentences, then the 50,000 sentences will be classified. That's the importance of being very careful about what is going to be retained as the input for analysis. All right. Good. So then we're going to have time, I promise, to apply these tools at the end. So related to that, before I keep moving, the presentation can be found here. I sent an email probably a week ago, 2 weeks ago, and you either can type the Kotlin link or you can scan it with your phone. Let me know when you are ready, in case you want to access the presentation. And also, we're going to have the handout, and the handout is a resource that will be continuously updated. So I will show it in a second. So the handout will be something like this. Let me just walk very quickly to what we have here. We have a workshop description as presented by AERA, the main guidance paper that spells out every single thing that we're going to be talking today. So this is the work in progress. It's on the revise and submit now. And then we're going to have a workshop syllabus in case you're interested. The presentation is exactly the same as this one, as this QR code. And then the updates to this document, exactly updates to this handout, because I will continue updating it. And then the presentation notes. The presentation notes, okay, I'm going to show the handout QR now. This should be the handout QR. And the presentation notes will basically be a just OneDrive file where that is live. So basically whatever I write in my computer, you can access it not only now, but in the future for you to keep the notes that we're going to be talking about, discussing. If you are ready with a handout, please let me know so I can move. Okay, going to move to the next one. Okay, so before well, if you happen to already have the handout, in the handout, you will also see the Windows application and the Mac application. So those are stored in a secure server, so they are absolutely virus-free. And let me just click on one to show. I'm using a Windows computer here because it's quite heavy. It's about 800 megabytes compressed. You just have to hit download to access the software in a Windows machine. Same rationale for Mac. Oh, were they? I think so. Oh, I think so. Yeah. Thank you. Wow. Maybe that was the problem before. So yeah, if it says Mac zip, it's a Mac. Thank you so much for that. All right. Let's try the other one. Let's see. This is download the Windows. Yeah, they are flipped. All right. So since the document is live, let's take 1 second to fix it. All right. So in the meantime, if you can please, all right, try to download it or start the download process. It should not take that long. So this will be Mac application and Windows application. I wish everything was as easy as this. All right. Perfect. So if you refresh your internet browser, it should just give you the correct version. All right. Sure. Yeah. So what we have just said is, once you have, do you have the handout already? No? Okay. The handout is going to be here. You can either copy that link or type that link, or use your phone to scan this code. HTTPS is column, right? What's that? Yes, this is in the presentation, so everything should be connected. Let's see. If you have access to this handout, you have access to the presentation, you have access to the links for the software. Yeah, the slides are under the presentation, but I made it live last night. It was inactive because I was still working on the presentation. So if you click this, should give you that. Sure. I click presentation. Yeah. Correct. Thank you. That was absolutely right. When I sent you the document, the presentation wasn't ready. That's the main reason. All right. So the most important thing would be to access the Mac application and Windows application. So once you download it, you will have a zipped or compressed file. And the only thing that you need to do is right-click on compress. Depending on Wi-Fi speed, it could take, yeah. That's why we're not going to be using it as of now. So we're going to continue moving with the presentation. I was told that, let me see, very quickly. I was told that if you connect to AERA speakers, the internet is faster, just FYI. And actually the password is exactly as AERA speaker. It's case sensitive, just in case that helps with the speed. All right, so we have the Mac and Windows versions. I think that we are just let it run, and then we will deal with that. We have time. That's why we have 5 spots in our time. Okay. So if we're ready, let's go back to LACOID. Are we all on the same page? Okay. So the main reason, the main rationale behind the use of, and this is absolutely true. We were working, my team and I have my student colleague in the background. We were working on some qualitative interview data, focus group data, and it literally, I decided to code 40 interviews by myself, and it took me 1 month doing nothing but qualitatively coding that. And because I have been using text mining and machine learning for a long time now, I was thinking that there should be a better way to, hopefully, time-based, more less expensive way to do this. But I was hesitant to see what we can actually learn relying on these data science tools, because as we will see during the presentation, LACOID is not panacea. It still requires our qualitative input. It's an integrative method, but it actually does a very good job in detecting nuances, and overall, the whole idea behind the text decomposition that we were mentioning about is something that the reviewers from this Mixed Methods journal were interested in LACOID to do. So that's why the first version that I submitted was only paragraph decomposition, and they were interested in the line by line. So I added the sentence decomposition. So it aims to get as close as possible, based on limited machine learning data science tools, to the qualitative or manual code identification. Still is a quantitative approach. So it's a toolkit for textual data classification. And the textual data classification applies literally to whatever type of text you have. Social media posts, job applications, interviews, focus groups. You can name, and we can discuss whether it could be applied or not. Aims to mirror the line-by-line manual coding. Aims to avoid aggregation bias by this decomposition. And LACOID comes with the standalone offline application for Windows and Mac, which means that you don't have to upload any data to servers in case your data is sensitive. You can do all the analysis locally in your computer. As of now, it's available for Windows and Mac. And that was one of the probably the most challenging aspects, because you can create what is referred to in data science as Shiny application. The Shiny application is uploaded to a server, and then you have to upload your data to the Shiny server or to your own server. But LACOID packages all this locally using, I will show you in a second, all the softwares that are required to package it. So it makes it free to maintain because we don't have to pay server fees, free to use, free to distribute, and hopefully free to expand based on your feedback and or your input. As I said, this comes from this idea of hopefully trying to democratize access to data science. There is a widespread availability of artificial intelligence, machine learning, etc. That as of now remain conditioned on computer programming, statistical programming, and software coding proficiency. So in reality, even though these tools are free, like in Python, in R, they are not open access. They are constrained. So democratizing data science aims to remove that constraint. And of course, LACOID is one of the first products of this movement. The other product is applies network analysis principles to qualitative data analysis, which is part of the previous workshop that I mentioned in that is now featured at the Journal of Mixed Methods Research. And so this is starting. If you have ideas for apps or inquiries, etc., you have the contact information right there. So this is just a little bit of a background of what is driving LACOID. So we already talked about the workshop materials. And how are we feeling so far? Do we have any questions before we start or continue formally? Please feel free to just ask questions whenever you want. Let's make this a conversation. For mine, yeah, I mostly use R. Cool. I am familiar with it. Yeah, it is. I think it's also based on a server. So it is the Shiny and other free softwares kind of make money out of placing products in the server. So that is a good business model for them, even though the applications are free. Yeah. All right. So let's see. So let's talk. Oh, yeah. It's exactly the same as it is. It should be, let me see, AERA, AERAS, capital, pickers. I used it yesterday and it worked. I probably should use it today. I don't want to disconnect from Zoom, so that's fine. All right, so very importantly, I think that LACOID is an integrated mixed methods approach. And one thing that I learned while working on its development is that there is this thing called fully mixed methods equal status design. And are you familiar with that? So this simply means, and very powerfully means, that one of the methods is not enough to actually get a good, deeper understanding of whatever we are trying to study. Meaning, we do have our data gathering aspect. Let's start with this. We start with the data gathering collection or the collection of data. This is typically the qualitative aspect of the data gathering process. or the qualitative input. Then we create our, via text mining, we prepare these texts as we're going to see that LACOID does. As you can see, what we are representing there, and as I said, I'm going to be a little bit repetitive because this is important. What we are representing there, this can be a single standalone file or document, which is going to be configured by a multitude of texts. What LACOID is going to do is to classify those texts. It's not going to classify documents. What's that? Oh, yeah. But the important aspect that I wanted to highlight with this multitude of colors here is that documents are configured by a multitude of codes or topics, not by a single one. That is what makes it necessary for us to, as part of the text preparation, we actually separate those text inputs, configuring each file. And at the end, we have to apply all these complex analytic procedures. But very importantly, at the heart or at the core of LACOID is that at the end, we're going to have a fully classified data set that will fully reconstruct the original files with the original voices of people. As part of the text mining, as we're going to see, we're going to apply normalization to words, normalization procedures to words to make them standardized across the procedures. Despite this application of the normalization, which implies that we're going to lose meaning because we're going to change some words, the final output, the very, very final output, will show both the normalized version of those text inputs and the original version of those text inputs, along with where they are located within their corresponding file. So we're going to have a lot of information at our disposal to see this. For example, sentence was classified under code V3. What was the context where this information emerged? So I can go back to the original text that we uploaded to LACOID and actually read the full paragraph or the full page where that input text emerged. So we can actually rebuild the original meanings after having classified these texts. This brings me to the first point I want to make, clarifying point. Oops, where are we? Should be here. Very important, we're going to be talking about files, which will equal the .c documents. Those will be the input files, and texts that will equal either sentences or paragraphs. Correct, thank you. And please don't make me confuse them, because sometimes, probably because of the English, I'll be referring to files as text. Please hold me accountable. Good. So there are two important aspects, okay? As I said, we're going to go back and forth. So the fully equal mixed method design implies that we can apply this wonderful tool if at the end we don't go back to the original meanings, we have nothing. We just are going to have a fully classified data set, but we are not going to even know what those codes mean unless we interact, unless we rebuild meanings. So this is just a tool. It's not the end product. It's part of a process. All right. Very importantly, because of the importance or the relevance of recreating context, recreating meanings, LACOID was programmed to provide us with visualization tools that aid with the decisions that we make. These visualizations tools will be frequency distributions of words by codes, for example, will be assessments of what is the most optimal or feasible number of latent codes that our documents or texts are supposed to have for us to actually obtain discernible information. That if we have codes that are basically so related that they are the same code, it is not useful for us. So we have to find ways to make them either not correlated or make a similar approach as dissimilar as possible. So there are four metrics that we're going to be using. That whenever you hit, give me the four matrices, is just going to be a process that is going to run the analysis 60 times at least and tell you, based on these 60 times 4, 240 iterations, you are likely to, and I said you are likely to have an optimal solution that is based on 3 codes or 7 codes or 10 codes. And then we have to assess which one is the best. So it's a crafting process, even though it's based on data science and quantitative approaches. In reality, we're dealing with the complexity of human rationale, human information on structured text. So we're going to be providing those tools that come along with the software. And yeah, basically what we aim is to actually don't lose the actual meaning of participants' voices. And by that, can be anything really. Thankfully, as part of the beta version of LACOID, it has been used in Spanish, even though it was designed to be working in English, and it is working. So I will tell you why it is working in Spanish, because the tokenization process just treats words as numbers. So it doesn't matter the language of those words. Yeah, please. Yeah. Is this here? No. Oh, yeah, okay. Here. What about that? Of this second part. Yeah. So yeah, basically this part is, we're going to talk more in detail, but it will imply the removal of text within your file that you don't want or you don't need to be classified. The example that we're going to be looking at is if you are interviewing individuals and you have your own voice as the interviewer. If you don't remove your voice, LACOID is not going to know that is your voice. It's just going to classify it. Your voice belongs to topic X. But we have to compromise and find a balanced way to not lose what you are providing to the interviewee. And I do have specific examples without altering the voice of the interviewee. And this is very particular to qualitative dialogue, but it can apply. We have an example of job applications where you actually have standardized headings for the job applications. So you should remove those standardized headings if you consider them as noise. You're welcome. Yeah, very good. So we're going to get back to the quantitative thread and etc. Let's just, yeah, this is very small, but you do have it in your computer. Let me see, I don't, yeah, and overall, even if these tools are powerful and are free, once more, they remain quite underutilized in mixed methods analysis and in qualitative research, likely due to the lack of easy to access software tools. Yeah, please. Absolutely. And we have to, in that particular example, it gets a little bit more complicated, the text preparation, because we have to find one way in which we identify the text input associated with who is providing us with the text input. Probably the one solution would be to decompose the files by participants before uploading them to LACOID. The resulting process will lose, by all means, the interactive aspect of it. But I'll be more than happy to continue thinking about how can we actually manage to not having to decompose them beforehand. Yeah. Oh, good. All right. Yeah. Yeah. Well, I do have another application that actually captures using network analysis principles, the evolution of information as it evolved during small group interactions. But the process that I follow to code those interactions is qualitative. So, but I'll be more than happy to share the resource as well. It's also another application, which was actually offered in the last year. It's called Movie, but I'll be more than happy to talk more about it. Yeah. Good to know. Good to know that this is the standard approach to decompose them. All right. So, good. Very good. So overall, LACOID aims to open access again to these tools. So I know that this is small. I will zoom in and start talking about this. So this is the overall procedural diagram. It seems a little bit text heavy. Reviewers wanted it like that. So after transcription compilation, we have to face the challenge of labeling, classifying, coding written information to its comparison, sense making, and draw conclusions. Typically, we have two options. Probably the most traditional and most prevalent is the MACOID, manual code identification, that typically we have to rely on specialized software, NVivo, Atlas TI, MaxQDA, etc. We can actually use Word, we can actually use Excel. In this process, unfortunately, it's quite time consuming. And one of the challenges is that it requires training. For example, in the case that I mentioned, I was the one coding for the interviews, was to avoid, we were in a rush, so I had to didn't have time to train or to reach consensus with my team. Then they check my decisions, but it was biased by all means, I'm sure. So validating intercoder reliability, etc. This keeps adding time and resources to the process. And I'm not saying that it's not important, by all means. Actually, there are some papers that have been traditionally used to assess whether the technique that we're going to be implementing today, LDA, latent Dirichlet allocation, performs closely to humans by applying the technique and then coding the same information qualitatively and then comparing the results. So by all means, if you are interested in gaining a very good understanding of what do you have in your data, you can code 10 interviews, you can code 10 texts manually to just get a sense of what you have and then apply LACOID. It's not going to interfere with your rationale or your findings, by all means. All right. However, typically, also in the Journal of Mixed Methods Research, there is a special issue where they analyzed COVID-related data, hospitalizations, people's perspectives about wearing masks, being vaccinated, etc. And that special issue implemented the machine learning and text classification to very quickly assess and implement strategies. So basically, they, after coding the responses of participants, they then conducted via these coded responses predictors of what demographics were more related to not wear a mask or to be hesitant about being vaccinated, etc., so that they propose some quick plans of action or plans of actions to localized interventions. So that's an example of how this has been applied recently. Natural language processing is what is driving or the main engine for LACOID. And here we need to rely on text mining, machine learning, data visualization, classification, Monte Carlo, Gibbs sampling. So all of this is packaged in LACOID for us to use. And I guess that I'm convinced, no, I'm guess that this process is reliable and time efficient. However, it is by all means not enough to actually capture. I'm going to say that a lot, to actually capture nuances and very deeper understandings of our text data. More specifically, as part of the preparation for the paper and the workshop, I had about 154 essays that we're going to be analyzing. It's going to be available for you all. And LACOID consistently identified between 3 and 7 topics. I decided to, for the paper that you have at your disposal as well, to analyze the 3 code solution. Made a lot of sense. There are some differences by demographics of the respondents. However, it by all means failed to observe that some participants in that essay, we're talking about 17 and 16-year-old kids, some of them had, at least in their essays, clear suicidal tendencies. And that was not captured at all by, at least not by the most prominent codes. So that is the importance of actually being familiarized with your data and knowing your data. LACOID is not going to be panacea. So that brings to the integration aspect of it, where the end is greater than the sum of the quantitative and qualitative components. And here we're not going to go into detail, but here in point number 2, let's just say that after the analysis is done, we're going to have, these are the results, 2 databases. One is going to contain all the codes and all the original and clean texts. And in this version, we can also have a trimmed data set, which is part of the same classification of all the text. And by text, I mean the sentences or paragraphs in this case, that can be used to rebuild all the files. And these will have up to 20 most representative texts per each latent code. The representativeness of these texts is important because it will allow us to clearly identify, based on this process, what are the texts that best convey the meaning of a latent code. And a latent code, as its name implies, is very much related to factor analysis. We're going to know that it's going to be a lot of correlation of the components, textual input associated with that latent code, but we don't know what those are. These are matrices, right? They're at the end of the day are going to be actual matrices. So we have to interact and see what is the actual meaning. The identification of these most relevant texts per code aid in the naming or in the understanding of those latent concepts. Then we're going to have an interactive distribution of the words configuring each latent code. This is going to be applying some network analysis principles. I'm very much interested in network analysis. That was part of the previous workshop. So the reviewers also wanted to see some network analysis. So I added this component. The main goal of this network analysis will be to demonstrate that even if a given file is most associated with a given code, it doesn't mean that it's the only code that file. And by file, I mean an interview or essay. But this is rather is the distribution of the latent code assignment is not uniform. There is a heterogeneity of that distribution. We can identify what was the most relevant code for a given participant, but that doesn't mean that it's the only code for that participant. We're going to show examples as well. Sure.
From number one there, when you talk about the 20 most what criteria would you the most representative?
Good. We're going to talk about that criteria in the actual aspect, method aspect. Basically, it will be what is the highest probability that a given text, sentence, or paragraph is affiliated with a given code. Yeah, it's just probability distributions. Yeah. And then we're going to have, it is not shown here, but as part of those databases, we're going to show as well, like within variation and across variation. In typically for the ANOVA, we're going to see, we're going to be able to assess whether a given latent code is actually quite well structured in terms of not having too much variation of the configuring texts. And to the extent that that value reaches 1, it will mean that that code is quite strong. And then within each topic, we're going to be able to observe what are the most important texts that basically we can, if we can take the most relevant text for a given topic as almost the definition of that topic. So if we read it, the most relevant and the second most relevant, we should be able to gain a good understanding of what is the meaning, because those configuration of words render or yield the most important probability of those texts being affiliated with that. And it will be only one highest probability per text to topic. So yeah, you're welcome. Good. Then we're going to see for a statistical assessment of group to code dependence that is very much associated with point number 3 here. And then finally, we're going to have a database measuring file to code strength. And I know that this is very abstract, but these 5, the 5th database or the 5th output will actually allow us to identify if I am participant 20 and I am mostly associated with code 2. And code 2, let's see, is about someone very depressed that has suicidal tendencies. I can take that data set and merge it with other demographic information of those participants, and then apply regression-based techniques to see what is the effect of me, even if I have affiliation to several codes, what is the relevance of being affiliated with that very bad code in terms of can I use it as an outcome in a regression model? Can I use it as a predictor in a regression model? So this 5th database allows us to continue applying quantitative approaches as opposed to just stopping the process here. All right, very good. So let's see, how are we doing? So we have been 1 hour here, right? Good. Very good. All right. So we're going to start the second aspect of the presentation. Do we have any questions? Second big section. We also have, if you want to take quick breaks, 5 minutes, we can all take quick breaks as well whenever you're ready. It would be ideal if we do it at the same time, but you can also just take a break. Yes, please. Oh, yeah. Yeah, for the meta-analysis, it's a complete different method. So yes, you will have to, well, there are a couple of things. Yesterday, I have been working on this software development for a while now. So yesterday I presented a paper where I'm using a similar approach, but to classify literature review. Meaning we have our corpus, and in this case, the corpus is a collection of PDFs that will need to be classified as a process of starting a systematic literature review. We're going to have very similar outputs. I'll be more than happy to share the paper and the software as well. However, there is no decomposition yet of those PDF documents because the parsing of the PDFs is quite complicated. But I think that that's as close as it will get to help with a systematic literature review, not meta-analysis. But we can talk more to brainstorm more. Yeah, thank you. Good, perfect. So let's see. So most of this has been said already. The main challenge is to classify or label hundreds or thousands of text inputs. As you may have noticed by the title, this is, well, it's over here as well. This analysis is for big textual data, and the big aspect of it is that the decomposition of documents into sentences renders thousands of text inputs to be classified. So it becomes quite burdensome. So doing it manually is time consuming, overwhelming, and it remains prone to human errors and inconsistencies. All right. So as I said, we're going to classify thousands of text in minutes instead of months with assessment tools, interactive word-to-code and text-to-code distributions. We're going to be able to formally test relationships and offer fully classified data sets that can be merged with other quantitative analysis. So this is nothing new. As part of the disclosure, machine learning requires analysis of words outside of the original context. That is for sure. We take them, we clean them, normalize them, place them in a matrix. So that is absolutely the result is that we're going to decontextualize them. So machine learning per se is useless in preserving the richness of the original and contextualized data. So that's why I place a lot of attention to the tools that we can use to retrieve those information. Nuances. Perfect. Let me see. I'm not missing anything here. Good. So as I said, we're going to retrieve the original sentences or paragraphs that contain the exact words as provided by the research participants and the cleaned and normalized text chunks that were used for the classification. So this is quite relevant because looking side by side, as we're going to see in a second, side by side, the two pieces of information will also help us in understanding the latent meaning of the code. As part of the text mining part, we're going to remove information that is not needed or that is considered noise for the classification. That will eventually yield the topics ascription, but having the two side by side will be an important tool for our understanding as well. So that's why we're going to preserve the original document name and the position of the sentence within that document. Meaning, like whenever you see, for example, text 1.35, the 35 will mean is the either the 35th paragraph in that text or the 35th sentence in that text. So you can actually go and look at it. As part of the disclosure, topic modeling leads to aggregation bias, as we have said. Actually, this is part of the comment that I was just mentioning a few minutes ago. This is a systematic literature review for tenets. We start with the specification of the topics of inquiry, of interest. We form our corpus, which is the collection of PDFs in this case. And then we apply the machine learning. And this is something that is going to be quite similar for both LACOID and this other approach. We're going to see, let me just spend some minutes here. There you go. Let me just go over here. This is an important, you can understand this as a quadrant that we're going to have it as an output for LACOID. The output would be much better looking. The quadrant would be as follows. Let me just make some notations. Actually, let me just look at what we're going to be doing in LACOID. Okay. All right. So here we go. Yeah, this is better. So here we have the quadrant that I was mentioning before. And then you will see the meaning will be that the codes that are in the same quadrant will be more similar than codes that are in a different quadrant. So code 5 and 7 belong to the top right quadrant. Code 5 has information that is quite similar, but not that much to code 1. Code 4 is kind of troublesome, it's all over the place. The content is being shared by all the other codes. That happens. We're actually going to see an example of what is the meaning and the implications for that. Code 8 is between the top and bottom right quadrant, and then you get the idea. So we're going to have this classification, and in LACOID, the little files that you see here, in reality, are the text inputs. They are not full files. They are sentences or paragraphs. And by default, I program LACOID to show you the top 5 most representative files. But if you want to see only the first or the top representative file, you have to slide it and select one, and it will update the result for you. If you want to see the 20th, you move the slider as well, in order for you to be able to analyze those outputs. Having said that, as I mentioned here, there is a potential for aggregation bias, because in this case, where we are analyzing entire PDFs and classifying entire documents into codes, we are losing the more nuanced understanding of all the containing text within those documents. So this is typically how topic modeling works, the current status of topic modeling. LACOID aims to address this by decomposing text. We haven't mentioned this last part over here. This will be if we decide to change names to reflect group ascription of our files, or the people who provided us the files, then we can automatically get this PDF. It's going to be a PDF that has a given chi-square value and the probability associated with that chi-square. And then we're going to see whether there are some participants who are less likely than expected to be affiliated with a given code in red, and participants who are more likely than expected to be affiliated with a given code. Once more, the question then is, what does that mean? The only way that we can address that question is go back and read what we have in our documents. This is just a tool. And this is the network representation. In this network representation, as we will see later on with the actual applied example, whenever we click on a given code, we're going to have some network matrices that enables us to see how relevant a given actor or participant was in providing code. The blue line indicates what is the ultimate code that a given group of participants or a given participant was more affiliated with. And we are going to spend time talking about what are the implications. This is just a visualization tool to basically demonstrate that even if I am more affiliated to a given code, I am also affiliated to other codes. Sure. On the right, yeah.
Version 1.
Oh yeah, this one, yeah. Yeah, exactly. Let's see. The V1, V2 is the default version of the latent topic or latent code. So these are codes, and this is a given attribute of the participant. In this file, we classified a little bit of context. This is part of the 40 interviews that I was mentioning before. In this case, I ended up classifying interviewees by whether they were whether they had a retirement plan, and the whole the purpose of that interview of that study was to observe or to analyze how faculty members in an job appointment that has no job security, like 6 months or less, are dealing or faring with retirements and saving plans. So there are some participants in this case that do have a retirement plan because the partner has a retirement plan. So they say that I'm okay. There are other participants who have nothing. So I classified those responses to see if these results were actually showing some structure.
So those are individuals.
These are groups, yeah.
Groups of individuals.
Correct.
Can you then explain what?
So this one. Oh, yeah. That's a very good point. So the narrowness or the height is the number of, in the same way we have, well, you see this length or this width of the connections is the same width that is telling us this group and B1 have very few instances of being classified on their code one. So this group and V1 are more likely to be classified. However, they didn't reach any meaningful significance. This, it gets a little bit confusing here. V2 and this group, which is quite small, are more likely to be classified under that code than what we would expect by random chance. So it's just the typical observed versus expected chi-square distributions. Which one? Oh, the dotted is just, in this case, is indicated the negative association. So the dotted lines all have negative values. The non-dotted lines have, how do you say not dotted? Solid, thank you. Continuous, I don't know. Yeah, thank you. Very good. All right, so the user interface, hopefully by this time you were able to download LACOID. The user interface is, you can do the analysis with about 5 clicks at least, or you can do it with 8 clicks. So this is the Windows user interface. The Mac user interface looks exactly the same. So about LACOID, let's see. So all these elements are shiny, neutron, GitHub are important in the compilation of this packaging. And so the process, just overall description will be as follows. We have just a short introduction, then we have the steps. We start by selecting the text decomposition that we are going to perform. As of now, I'm not allowing LACOID to classify full texts. If there is something that you are interested in having the option to, be more than happy. It shouldn't be that complicated to classify full texts. And the reason is to avoid latent code aggregation bias. By latent code aggregation bias, I mean losing the nuances by classifying entire text under one single topic. All right, so here you just have to select whether you want to decompose your DOC files. Doesn't work with DOCX because DOCX has HTML code embedded that creates a whole set of difficulties. Actually, the original version of LACOID was TXT files. The reviewer wanted to see DOC files. So again, it was more complicated than I expected to be, to just make that change. Okay, sentences or paragraphs, whatever you want. So then after selecting that, you're going to see here that 1 and 2 is just going to be referring on the top, data decomposition information, based on what you upload to LACOID locally. You're going to get a message over here. And this is going to tell you 2 things. One is how many sentences met the inclusion criteria. And by inclusion criteria is, as we're going to see later on in the presentation, as I said, it's going to be iterative because there is a lot of things going on at the same time. The inclusion criteria would be, if we want to be very nuanced and decomposing at the sentence level, there is a chance that some sentences make no sense, that there are incomplete thoughts, or they are just based on, for example, the description of a job or a section description will be 2 words or 3 words. So those by themselves make no sense to classify. So what I program LACOID based on linguistics is that the average sentence length that conveys a meaningful information in the English language is about 10 words, 9.8 words on average. And we do have the references in the paper and the presentation. So I said, well, we can retain sentences with at least 10 words in length, which is observed here. By default, is 10 words in length. If you are willing to just move it and set the threshold to 5 words in length, it's just a click that you can do before uploading the text. If you are interested in just having sentences with at least 30 words, you can also do it as well. By default, based on experts on the topic, I set it to 10, but you can actually move it. And of course, yeah, sure. No, please.
Paragraph, sentence, you have to be 10 words.
Most, like probably 99.9% of a paragraph has at least 10 words. Yeah. So the machine is going to apply the same inclusion criteria for sentences and paragraphs, but since paragraphs, most of them have more than 10 words, it basically ignores them. Yeah, because it meets the criteria.
So there can be short sentences within paragraphs.
Mm-hmm.
But paragraph is still, the paragraph will be included with 10.
Correct. And that's a very important clarification question as well. The paragraph will be separated by a blank line or by a period at the end of the paragraph. So that is how LACOID will identify these paragraphs. If you want to be 100% sure, you separate your paragraphs by a blank line. Yeah, please. As of now, whatever you select is going to be applied, so you cannot merge it. So if you have, if I understand the question is, well, could you please repeat your question? I don't want to put it. Mm-hmm. Probably sentences, yeah. So so if you select sentences, what is going to happen is when it detects a period within a paragraph, it's going to separate it. That's a very important point. So it's going to separate based on a period within a paragraph. Doesn't have to be a full period. Yeah. So if your sentences, and that's something that is really truly easy to fix. If your needs are for your analysis, for example, are the inclusion of a minimum threshold of 3, just tell me, and it's very easy to. It's literally just adding a 3 in the code for you to be able to include. Meaning that if most of your job descriptions or whatnot are 3 words or less, if you have the 5 as the minimum threshold, what you're going to see is that most of your text will be dropped. Yeah. All right. So this output will be the result of this selection, sentences or paragraphs. Let me just see how it looks like. Let me see. Okay. I should have it over here, I guess. Revisions, transcripts. So actually, school leavers, yeah, you will have access to this data set. So it looks like, let's just take a random text over here. A file, actually. Told you I was going to confuse it. So this is how it is specified. Here we have boy 16_20. It says, I left school when I was 16. A little bit of context. This is a very beautiful study. Anthropologists in Great Britain asked 6th graders to imagine 30 years from now, what is of your life, what has been of your life, and tell me what were the reasons why you left school. So the study is called School Leavers. It's a very beautiful study. So these are 16-year-old kids telling the story of their lives as they imagine it happened. So just reading them is a treat. So you can see here you have a period. If we select sentences, whenever we upload this document, this will be an input file, input text to be classified. If we select paragraphs, this will be the input text to be classified. As simple as that. And In this case, there was no much information to be removed. I think that the original database comes in RTF, rich text file, I think that has a little bit of a header and whatnot. So I removed those extra information pieces, and I say this a DOC, as simple as that. All right. So I have, whenever you are in LACOID, you just have to go to your, sure. Are you a Mac user or a PC? Yeah, I'm asking because a Mac has this automator, is a little robot that you can program to open each file and save it as whatever extension. It is, I don't think that is possible in Windows, but I'd be happy to do another search to see if we can. I'm sure that there should be some options. Any other questions? Yeah. 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 So, so as part of this study, as part of the data released by Paul, 1978. So he provided this SAAD, ID, gender, age, and this is something that I will be showing for our analytic purposes, because I changed the name to something that I wanted to analyze. I wanted to see whether group ascription by the intersection of gender and age was going to be affiliated or associated with some topic ascription. So I basically just added this column, but this is my meta data. So if I wanted to, after classifying all this information, I can merge this, the classified data set by this column. This will be my key indicator. And I can regress whether gender or age, in addition to the testing that I'm going to do with the chi-square, is affiliated with the probability of being in a given code. Yeah. So does that make sense? Sure. Yeah. They will become the decompose. Let me just back up a little bit and please tell me if I'm making sense. So the original file is named as this, and this comes in a rich text format. What I did is, let me go back here. Where are we? PDF here. That's totally fine. There you go. Yeah. Let me start again. So this is the original file, the original name of the file. This name by itself doesn't allow me to text for group ascription and dependence or association with topic. So what I said is, I do have a gender attribute and an age attribute. I will create an ID that captures that for the name. So this, what I wanted to show is, this is my database. It's a little bit small. Let me see if I can change it. Probably didn't help that much. Extra large icons. So this will be the boy 16.1. The important thing that we're going to discuss later is that I'm going to add a number to each of the change names so that based on data manipulation later on, I'm going to be able to remove that number and just get the group ascription. This is the example. We have the original name is case 1 inside 2 of the file. Interview 3, case 2. That's the name of the file, the original. If I wanted to do a test, I say, well, this is a man, and I'm going to add a number 1. This is a man, I'm going to add a number 2, so that I can differentiate that these are different input files. Internally, the process is going to keep the different, and I'm saying this because as part of LACOID, as I said before, I am very much interested in retrieving the original information. So this manipulation is to actually not lose the original information. So we have man 1 is associated with this. Man 1.2 is the second paragraph or second sentence of that file. If we go to woman 1.3 is the third sentence or third paragraph associated with this file. As part of the analytic process, I can basically merge all the information that comes from man 1, man 2 by removing the number. So, but internally, I'm keeping track of this one. So that is part of the black box of LACOID. So that at the end, we're going to have the fully, the possibility of getting fully aggregated by group analysis as here, but also a fully disaggregated analysis as here. In reality, it just looks like you have your original name, have to keep track of what is the original name as we have in this file, and place them all in a folder. You place them all in a folder as we have here. Let me see. Select them all and open. So now the first part of the text analysis is taking place. We have 153 files. And we selected as a minimum of 10 the sentence length. Sure. Each paragraph, yes. For paragraphs, you have to just select paragraphs. Oh, yeah. So I would recommend to place them in a spreadsheet and upload a spreadsheet to the classification. Yeah, but that I'm using that approach to close open-ended questions, if that makes sense. Typically in survey analysis, I was analyzing a survey from California. We had 3 open-ended questions, and the survey was 67,000 people. So 3 times 67,000 is a lot. So what we ended up doing is to apply this same technique to each of the columns. So it's quite similar to having one single file with multiple respondents.
Sorry, would you be uploading?
For the other software, yes. For this, it's only DOC. Yeah, but that paper is also ready, so I can share it with you as well. Yeah. So that is for closing open-ended questions. Yeah, the same process applies. So let me see. Oh yeah, it took a little bit. I was worried that it didn't tell me. So the feedback that you get here is that you uploaded 153 files, as it's shown here, and it tells you these files were decomposed. Oh, I selected paragraphs. Were decomposed in 1,106 paragraphs. And then the text mining procedures, let me see. Of these 169 had less than 10 words. Okay, so this is, I said that there is probably not very likely that paragraphs are going to have less than 10 words. As you can see, it may happen. So there were 160 text chunks that had less than 10 words, so they were excluded from the analytic process. And here, that's something I haven't mentioned. You can actually download that file. Let's see. They will have 2 extra files that you can download. Let me see where it is. Should be in my download folder. And this is telling the following. This is just the frequency distribution by the naming of the groups that we have. Why is it not? So we have 89 files classified as boy 16, 13 as girl 17, 51 as girl 16. So that is just the frequency distribution of that. All right. I don't know why it's not responding. All right. Let's see. And then there is another database that at the heart of LACOID is transparency. Transparency, full transparency in the analytic process. So here we can see what were the paragraphs in this case that were excluded because they didn't meet the 10-word criteria. So here we have, I think that we have 169, right? 169 of them. And then this is considered, if we go to boy 16 document 1, let's actually look at that. Boy 16 document 1, let's open that. And this is the file. It starts reflections. So LACOID said, well, based on your understanding, that is a paragraph because you have a blank line after that. So, but also based on these criteria, this doesn't have 10 words. So we're going to exclude it. So it's transparency overall. So we have, that is the text that was excluded. If for any reason you want to fix this text, you have to go back to the original text and fix it. I don't know if you merge it to the next paragraph or to complement the actual information that you think is missing. It is your call. And then this is just extra information that we don't need. And in software development, we start counting by 0 instead of 1. So that is extra. Yeah. Oh, yeah. You specify with the name that you want to add. So this is exactly connected to this process. So here I named these files based on these 2 attributes, male and 16. So I said boy underscore 16 underscore 1. And if we go to this boy underscore 16 underscore 1. So we added the numbers at the end so that in the process we can remove the numbers and just count the number of times that boy 16 appeared. And the number of times that boy 16 appeared was 89. So that is how it grouped these responses. Does that make sense? So? The files. Correct. Correct. It's just based on the names of the files uploaded. Correct. Yeah. I told you, yeah. Yeah. it doesn't think by itself yet, thankfully. Good. All right. So transparency, here we have reflection, reflecting, and you can go and analyze, like, for example, this was a paragraph, Steve, you're home early, I'll get the dinner ready. You are home, I guess. So another interesting thing is that because this is verbatim, I didn't fix any grammatical mistake. I just wanted to test how the software performed with the voices of the participants. And as I said, this has been applied also to Spanish. So that shouldn't be a concern. All right. So those are two extra pieces of information that are given, just a little bit distribution database. In case you didn't change the names of the files, you will have these file names over here, which would mean that this distribution table is still going to be an output. You just will have 153 rows and the frequency will be 1. So that will be the main difference if you don't change names to standardize them to something. Yes. Good. Right. Perfect. So let's keep moving. I'm just going to show you the steps, and then we go to the black box in the next section. All right. So let me just do the sentences over here. One thing that is a little bit annoying is that you have to, if you change your mind and still instead want to analyze sentences, you have to upload them again. So it should be uploading them. It's showing you this thinking. And the big data aspect of this is we have 3,000, now we have 3,222 sentences that were decomposed from this 150 file, 53 files. And in this case, we removed 768 texts. Let's do this very quickly. Let's take a look. And should be this one. Still thinking. All right. Downloads, chunks. Okay. Was thinking. Very similar. It's going to be longer in this case because we have more cases that were once more. Here you have the way we read this is the document number 1, the first sentence. And if, for example, you read this one, Gear 17, 153 document is the document name, 44 is the sentence number that has this text. Meaning his trade was a plasterer. I don't know what that is, but that is verbatim. Sure. Correct. As long as you consider that having 5-word responses is meaningful, that could be a concern. Absolutely. Yeah. However, having said that, the reason I provided this file that we're seeing now, it will allow you to actually observe whether there are some interviewees who are more likely to be in this category, in this classification, and potentially either reduce the number of words as the threshold for inclusion, or merge the responses so that they are longer. So, but those are part of the crafting of this analysis, because there are a lot of intrinsicies that that appear when dealing with humans and the complexity of human interactions. Yeah, but that's a very good point. Okay, one more thing I was going to say about that. Let's see. Well, hopefully it's going to come back. Right. So I'm showing these, and then we're going to take a quick break, and then going to go to the black box. The text mining aspect of this would be as simple as execute text mining over here. Here we have the number 3, and the number 3 is going to also give us an output over here. We're going to see a couple of pieces of information. This is very important as an iterative process. There is the possibility that quite outliers, very uncommon sentences will still be dropped. And then we're going to see again what those sentences were. So with the text mining, so this is a little bit more computationally heavy. We're creating matrices. Here you go. Here we 27 more text chunks whose content was too uncommon to aid with a meaningful classification were removed. So you have, and then you can see which texts were these. Once more, very important, you have the sentence location, the file name. You can go and observe them, possibly paraphrasing them. I'm not recommending that. I am very much into keeping as close as possible the meaning of the original voices. But you as researchers and your research team have to reach a consensus about how to proceed if you want to preserve those pieces of information. These are basically outliers in the responses as a part of your collection or corpora or corpus, however we want to refer to the collection of text. Yes, please. This is correct. Yeah. Yeah, this will tell us from an text mining perspective is based on sparsity. So these texts will not be part, based on this 98%, will not be part of the 98% most common information. So those are the top 2% whose configuration are very uncommon in the matrix. So yeah, that is exactly it. If you are interested in the nuances of outlier data from a textual perspective, and very importantly, once more, this is the original text. This is not a cleaned text. Sure. Well, this one, sparsity? Oh, yeah.
Use acronym, use the whole word. Are you able to you manually go in?
Yeah, typically we will have to fix it if we want to. Yeah, if we want to do that type of analysis. Like for example, I was applying this technique to a policy analysis of Afghanistan and the presence of the United States and Afghanistan, whether they should remain or not. Some of the policy commentators were using USA, some were using the United States. So I had to just search and replace to a common one. Yeah, but yeah. All right. So here we have the original text that were executed, dropped. So we have our remaining database will have 2,427 remaining text input. Our vocabulary, which we're going to explore more in detail in the next session, is 200 words. We're going to see what that means. Then we have that the maximum term length for a given sentence as cleaned, as prepared. Oh, I remember now what I was missing before. Is 14. So One very important thing that we have to acknowledge, and I'm going to, forgive me, I'm going to jump a little bit over here. Yep. Yeah, there you go. One thing that we have to acknowledge is I have been mentioning the threshold being 10. Let's take a look over here. Where is the threshold will be 10, but that doesn't mean that 10 is the minimum inclusion, minimum threshold for inclusion. It's very confusing. This means this text over here has 1, 2, 3, 4, 5, 6, 7, 8, 9, and was retained in as part of the classification purpose, because the original text has 13 words, if I'm not mistaken. We can count them later if you want. Has 13. So this text met the inclusion threshold when uploading the file. However, after the cleaning took place, our final number for a given sentence was 9. So that means that we can still analyze sentences with fewer than 10 words, as long as the initial length of that uncleaned sentence was at least 10 words. So just conceptually, this is what is going on in the black box of this preparation process. If this is not clear, please, I'll be more than happy to elaborate more. All right. So this is a little bit of an advanced organizer, talking about the word frequencies. There is some important research. All of this is in the presentation. We're going to cover it with proper citations. There are some concerns that very, very common words don't aid in the classification of text. Like, for example, if you are interested in an issue associated with college readiness, probably your respondents or your literature review or your text inputs are going to have the word college and readiness, etc. So whenever you do the word frequency cleaning, if the most important words and with the highest frequency are those, probably you don't need them in your classification process. So here you can decide to remove them. And the removal of words showing the first 10, once more, if you're interested in more than 10, I can update it to show 20, 50, whatever, will be, let's say I am interested in removing the second word and the 9th word. So you can just say, this is the 9, this is the second. So you can say 2, 9 and trim the document. Let's just do it for now. So it's going over the matrix. It's a quite big matrix, so it doesn't take that long, but it's not as fast as well. So it has been removed. So this trimmed matrix is the one that is going to be used for the classification purpose, in case you wanted to remove very common words. Does that make sense? And that is just once more, if those words you consider, once more consensus, decision-making, transparency about what to remove or not. Yes, please. Correct. Those are called stop words in English. And part of the reason, thank you for asking that. Thank you so much. The reason why this is shorter than the original text is because we removed those stop words. Yeah, good. We can also remove numbers. I decided not to remove numbers because they convey meaning. Please. No, as of now, if so, these are you familiar with word clouds? So word clouds is basically the this will be a word cloud representation. That if we put it in a word cloud, year will be at the center, the largest, indicating that this is the most frequent. As of now, the way we remove it is by selecting which one of these words should be removed. Yeah, so we cannot, basically it's the same rationale that you said, but not in sentence form, in word form as a function of this. It removes the hyphen, so it becomes one word. Correct. Oh yeah. Correct. Exactly. You can. Do you want to elaborate? Yeah. And one of the very powerful things of this topic modeling approach is that even if you are not dealing with proper English, or you're dealing with slang, you're dealing with grammatical inconsistencies, as long as they are consistently inconsistent, you are going to keep them in the analysis. Once more, even in a different language, it will tokenize those words and consider them part of the vocabulary. So hyphenation, once we remove the hyphens, then it becomes a standalone word that may be classified or aid in the classification. Good questions. So let me see. In reality, let me just do it again. I didn't want to remove those words. At the end of the day, it's not going to change much because it's only 2 words. But I wanted to replicate the analysis that I'm going to show in a second. All right. Any other question while it finishes? So as you can see, for me to execute the text mining, I didn't have to upload the file again because it saved the original version of the uploaded files. Only if I needed to change between sentences and paragraphs, I need to upload again. So it should be Mary is 9. Good. Okay, good. So if you don't want to remove words, you don't select anything here, and you don't select this. All right. So one thing that we're going to see in a second is that the initial topic allocation is going to be based on a random process. And that raises a lot of eyebrows all the time. We literally first have to select how many topics I think should be optimal in classifying this wealth of information. That seems to be a very random process of selecting. I think that 5 topics are going to be good enough. So we're going to see how to assess how many topics are the most optimal. And after assessing how many topics are the most optimal, we randomly assign these words to topics, not sentences, but words to topics. And from there, we started learning process. This is why the learning process in this version is based on 5,500 iterations. And those are the standard, the standard in the field, saying the burn-in samples in machine learning just indicate that I know that the first iteration is random. The second iteration is going to be an improvement because I'm going to learn what happened in the first, assuming that all the remaining classifications were correct. That's a humongous assumption because it's based on a random process. The third is going to be based on the previous two. That's the chain in Markov chain, and so on and so forth. So what we're going to be doing is, after 500 iterations, we're going to have a good prior, a decent prior, but this is not where the analysis ends. We're just going to discard that and start the learning process in the 501 all the way to 500 and 500, 5,500. So we run burn-in samples that are not going to consider and start the actual learning process with the 501 based on everything that we learn. If we are concerned about being more rigorous, you can simply say, I want to discard 1,000 of them. And I'm going to learn the process 10,000 times and execute. It's a little bit more time consuming. So for now, let's keep it at the standard 500, execute the matrices. We're going to see. So in PC, I'm speeding up the process by taking advantage of all the cores that are in my computer. So this is asking me to access all the computer power that I have. For Mac, you don't have to worry about that because it's not taking advantage of your cores. Unfortunately, it's one thing that Macs don't allow with this approach. All right, so what we're doing here, we're going to have, as I said, we have to have a good understanding of what are the optimal number of topics or codes. Latent codes or latent topics is the same. That should guide our classification process. The matrices, the matrix that we have here are going to be that evaluation. And we're going to talk about what does that mean. Yes, please. Correct. The standard in machine learning, yes. Yes, exactly. Yeah. Actually, in the paper. There you go. This is the seminal paper. Raftery and Lewis, they have a lot of simulations, and they concluded that with 500 initial learning process in the burn-in and 5,000 iterations, they didn't find much more improvement by increasing them. According to them, no. One thing that the decomposition that we're looking at implies is that our matrices are going to be larger. For example, if we have 153 files, and we consider each file as a document or as a text input, our matrix is going to have 153 rows plus 200 columns because the vocabulary is 200 that in that matrix. But because we are decomposing them, this matrix is going to have 2,700 rows because of the sentence decomposition and 200 rows. So it increases quite drastically. And at the end, the matrix manipulation is quite computationally expensive. So even if the sentences are small, the computer power required to run it is still a lot. But going back to your question, you should not lose anything by increasing or decreasing. You should not be concerned about the length of the document that you uploaded. Does that make sense? Okay. All right. So let's see. If you are interested, we can take a break while it runs. It probably takes 5 minutes. And let's actually take a 10-minute break is good. Okay, let's go back at 10:15. It's 10:04. Thank you. Sure. Sure. Absolutely.
So I tried the
Oh.
same data set as you, the
Oh, yeah,
school
yeah.
papers,
Yeah.
the DOC files. And it looks like an
Oh.
R error, and I'm not really good with R. So,
Good, good, good.
I'm not sure what that means.
Let's take a look. Let's take a look here. So the same question, the same problem is a math, right? Yeah. So where do you have, you guys, your LACOID? Exactly.
It's in that desktop.
Perfect. Let's take a look. Because there has been some issues with Mac users. Let's take a quick look. No, the folder for LACOID.
Oh.
Yeah, exactly.
Are you trying to on yours?
Mac, yeah.
But I also had to go into my system preferences and tell it to allow me to open it on application.
Correct.
That isn't verified.
No, I did that already. I can't access the DOC file.
Oh.
Very good. Let's take a look here. Right click, show package content. You have to go to the resources app. So this is the source code. And then we have let me take a quick look. I think that I have no, that's fine. No. I don't need a break. I have enough caffeine. Let's see. Should be, where is our, here. Yeah, for Mac applications, there was an update that is interrupting this process. So we have go to contents, go to Mac OS, Electron Quick Start. Let's see. Do you want to try it in yours? So contents, Macos. Oh yeah, just double click that, please. Let me see. Double click. Is it uploading? Good. Good. Very good. So
do I
let's
do that every time now, or is it fixed forever?
I think let's see if it works.
Okay.
Because I have tried with a different application, but let's try to upload your document, please. And if that is the case, as of now, what we have to do is just create a shortcut of that one to your applications. Right. Yeah. Good. Oh, let me see. Can we take a look? So you double click this. Oh, really?
Yeah,
Same?
same problem.
Well, probably. Okay. Let's see. Very good. So it should be this. Yeah, so you can run it. That's totally fine. Run anyway. Very good. Let's see. Hopefully, we have to reload it here to create all the paths in your computer. Right. Let's do it again. Okay. What is that? System commenting or file private. Another word document. Yeah, that's telling you that you don't have a DOC file, do you?
Do I need to take everything out of the folder that's not a DOC file?
Not really, no. What you can do is just select a couple of them and see if it reads them. Yeah, very good. Correct, that is the interface, yeah. And do you have the files that you want to upload? Okay, let's try that. Yeah, hopefully. Sure. Very good. Just double click. Oh, you have it open here?
Thank you.
All right.
Yes.
Yeah, with this open freeware, there is a little bit of a pain sometimes. So you close it, right? Very good. Let's do it. So what it does, it overrides any issue that. So what we can do is, the problem is when downloading it from the server. If you have a USB, I can give it, I can create a copy so that you can have it in you. You don't have to download it from the server.
Okay.
And that should solve the problem.
But that shortcut to the
That works.
that would solve.
Yes, that would solve. It is something that there is no information whatsoever on the internet as to how, why it is happening. So they just know that there was an update in Google, the server for the university, and it stopped working.
Thank you so much.
You're very welcome. I'm glad it worked. Okay, let's see. Let's try to open a couple of files. Yeah, let's see. But do you have any DOC file? Just to make sure. Oh, okay, good. Sorry, I didn't see that. Great. Very good. Oh, okay. So what you can do is just open the original file and save as DOC.
If I do that, I can see that file.
Correct. Correct. Perfect.
I have shortcut.
You don't need a shortcut because you're a PC.
How do I open this?
Oh, I see. No, you need a shortcut.
Yeah.
So where is it? Let me see. Yeah. No.
Okay,
Let's take a look very quickly over here. Should be here. Let's create a shortcut.
sort of,
Wasn't like that.
Oh, let's close this. And let's see. Yeah, this will be. I'll be right back. But all right. Hello. How are you? Thank you for coming. How was the trip? Good. Yeah. And when is your presentation? What time?
But this plate
Mhm. Yeah, you should. Okay. That's totally fine. All right. I will see you in Chile. Bye. Good. Hi. Hi. All right. We missed a little bit. So what is the most important definition or concept describing a given topic one? We slide it to one. And here we see, and once more, you can download these data sets that we're going to see in a second. Here we're going to see topic 4. or latent code number 4. The text that we can go and actually read to the original file is text number 30, sentence 5. So this is telling us what is the relative text contribution. This is telling us how relevant this text input was to help us understand topic 1. So this is the most relevant. It has a value of 1, the maximum value of 1. So this relative group contribution is how noisy are all those texts classified under topic 4 in helping us find coherent results of this. In this case, it's a 7-topic solution. I'm going to elaborate a little bit more on that, but here we have quote. Quote is as it is in the original file. Once more, very much emphasis on retrieving the original input files as expressed by participants. When I had first started, and then you can read it all. So that is one sentence. It's a quite long sentence. But this is the initial input sentence, and this is the text mined cleaned result. So there are going to be a lot of information that didn't make it to the classification. But that's why we needed to have the text version, the text cleaned version, and the original version. So here we have, instead of giving you a count, it only repeats the number of times. If we read this sentence, we're going to see that there are 2 aways, and then bank twice, change first. So by reading away, away, bank, bank, change first, friend, house, house, leave, 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 money, rest. So probably this is something related with buying a house, getting a mortgage. And that is just probably because I already read this document, but it should give us a good understanding of what is happening. If we wanted to see the top 2, we slide it, updates it. We can say, for example, for topic 1, this is the most important contribution. This is not as coherent within the code as the topic before was, but we can still understand this sentence as the most representative, based on this one, sentence, the most coherent sentence describing this latent topic. So we don't know what a latent topic is. We have to understand what it actually means based on the meaning. Does that make sense? All right. And just very quickly before we move, so sure. Yeah. Group fit. And by the way, all of this is in the paper as well. But group fit will tell you, like very similar to ANOVA, whenever you have within group variation and across group variation. Within group variation is bad, like noise within your treatment groups and comparison groups may not allow you to find significant results. So that is overall the rationale. To the extent that you have low values here, it will mean that your words configuring this topic will be part of many other topics. Does that make sense? So all these words will not only be describing topic V1, it will be used to be describing topics V2, V3, Vn. Correct. That is the meaning of, the closer it gets to 0, the worse the relative group fit will be. There is no consensus, absolutely no consensus. Yeah, and actually As we are going to see in the next explanation, very importantly, let me just show you very quickly over here. Very, very importantly, there is a lot of caveats with topic modeling. Let's see. What we're going to have is, this is very important, a very important table. Here we have document one, in this case, can be a text input one, or a sentence, or a paragraph, or can be a document. May be associated with code one and code two, and the let's understand this. Document one has a length of 8 words. 4 words were associated with code one. 4 words were associated with code two. So there is a 50-50 chance of document one helping us explain code one, and document one helping us explain code two. Meaning, what does this mean? It's noisy. There is no structure. It's not better than random chance, right? That is bad for us. Document two, or the text input associated with document two, gives us a 61.5 chance probability of being associated with code two. If after repeating this process 5,500 times, we still find something like this, what is going to happen is that we're going to take the highest contribution, which is this, to represent that code two. So we're going to find across the 3,000 text inputs, what is the most important contribution of a given text to a given latent code, and that is this number. That doesn't mean, sorry about that, that this text only is associated with that topic. That is the very important caveat. It is associated with other topics. It is only across the entirety of our corpus that is the most representative text of that topic. Correct. That none of the other topics have those text inputs over here. Yeah. Good.
Relative text contribution is
no, it is the most relevant contribution, not 100% always. It is just, as we said here, in this example, the best contribution is 61%. And that will have a value of 1 at the end. Yeah, it doesn't mean that is 100% of the time. Correct. If everything else equal, and after you run the models 5,000 times to learn the distribution, etc., that will be the number associated with it. That is very important. And going back to your point, typically in latent topic modeling, we don't even describe this value of 1. We stop the model with this distribution. However, and very much related to this, here we have most representative cases, LACOID, a phi to LACOID distribution. Let's take a look at this. Phi to LACOID distribution. So that file here, first of all, we have seven code solution in this case, not the third. So this is going to tell us, this is what we can bring back to this file after removing Actually, we don't have to remove anything. Good. Excellent. Yeah, it retrieved everything. Good. So here we say voice 16.1, the first file, not the text inputs decomposed, the entire file. Here we see, which one is the highest? 15.4, 19, 15, 23. Yeah. So here we say this file was the most associated with topic 3, with a frequency of 6, which means 23% of the contributions of that individual were placed in topic 3. So here you can start looking at what is the most conceptually for your own research, what would be the most relevant latent topic of these 7 topics, and then identify who were the participants who were the highest associated, even if it is a difference between 19 and 23.1, who were the highest, had the highest association with that topic of interest. And then you can start looking at your own quantitative modeling approaches as to how to treat. Do you want to treat these 23 because it's the highest will become a 1 versus not the highest for that? You can binarize, or create a binary indicator of this, or you can just treat it. I'm just going to consider this as a continuous indicator that will give me a value of what is the proportion of times or the percentage of times that the responses of my review of my participants were affiliated with the most important latent topic of my information. That another analytic decision that we have to take. There is a question? Yeah, sure. Correct. Oh, thank you for asking that again. Because the relative group fit, what is different between this table, this table and this table is that here we are analyzing the decomposed text of a file. What we are analyzing in this table is the aggregated at the file level distribution of how, like for example, how total number of times that this participant provided text input, which means that text input had 26 sentences. 26 input sentences that were classified across 7 topics in this case. Of those 26, 23.1% were classified under V3, which is different to say across all 3,000 text inputs, regardless of who provided us with those text inputs. This is the quote that is most representative of that. So they are very much related, yet different. It's a lot. I know it's a lot, sorry. But those are just tools. And you don't have to use all of them in a single paper. You can decide to do the aggregated analysis, meaning for this piece, or the disaggregated analysis for this piece. It is quite unlikely that you're going to be able to analyze the 2 of them in a single paper, unless it's a dissertation or something like that. So basically, the full LACOID data set with all text chunks will include all the 2,000 or 3,000, I don't even remember how many of them we have, or 7 entries. Yeah, this is just for the top number one. So let's just take a look. Come on. Let's see. Fully machine learning class. Let's see. This is going to have 2,428, which will be the disaggregated analysis. In this case, we're going to be able to rebuild all the 26, if I'm not mistaken, yeah, 26 contributions that were used as text inputs for the first document. We see by the first 26 rows. We're going to be able to basically rebuild the entirety of the essay as depicted by this quote. And also analyze, if we want, the cleaned version or the text mined version of this content in that data set. ID. Oh, and then we have, of course, the relative text contribution as associated with this text to that code. Very importantly, before we move then, recall that this particular text may be associated with more than one code. We are just highlighting the highest contribution to the code to which that text contributed the most. Probably I repeated it. Yeah. All right. Question. Good. Oh, good. So that's a very important. I think that we collaborated on this because we are asking all the right questions. Really. So the relative group contribution, by its name, means that the number that we have here will be the same across this topic. Meaning that if we this is 92.6. Whenever we see V2, it's going to be 92.6. So if we say data, or filter, and say, let's just take a look at B1, it will be a constant. Yes, so it's aggregated already. Good. Yeah, you realize that I really don't have a life. All right, good. So many things. I think that, oh yeah. Then, oh yes, we have this one. Let me just, for the sake of consistency, let me just very quickly run the 3 code solution. Very quickly over here, execute LACOID. So quite relevant. I think that this is going to just save this file wherever you have LACOID installed. It's not a temporal file. This will be accessible as long as you have. So you can take this file and email it or upload it to your server. This one is compiled internally in your computer and then presented in this form. So you cannot distribute it as is. If you are interested in uploading it to a server, let me know and we can definitely do it. It's called a GIST, G-I-S-T, that we can upload to GitHub or any other server. So here what we have is the distribution of, here is going to be the groups in triangles. This is going to be the codes in circles. What this is doing is creating a community algorithm. It's running an algorithm to detect whether the density of the connections is actually discerning as well who belongs to a given community versus not. So basically this information B2 and B3, based on the density of these relationships, belong to the same community as depicted by this color pink. And this participant, which means girl 17, is associated with this community. And this participant, girl 16, is associated with this community. Based on the understanding of what B2 and B3 means, it indicates that in this case, women in the sample were more affiliated with these communities. But we're not testing for whether that is significant or not. So here we have that this is the boy 16. It belongs to this community by itself. And B1 will be the one that where they start going to work, that they find a house, that they, etc. So this is just a depiction. This is telling us these codes and this group have a frequency of 71 sentences associated with that code, representing 43.6% of all the contributions made by that group. Here, this one, as you can see, 586 sentences were affiliated with that code. That is the width or the importance of that connection, 43.5, 37.5. So the length is important, the width is important in this depiction. And finally, the last thing that we haven't seen here is once we run the analysis. Let me see. There you go. Hypothesis test. So it's going to be a PDF file that you can open, you can save, you can distribute with your papers. Okay. So this is basically the same depiction that we had before, but this is, we are now testing whether certain groups, in this case, there is one group of women 15, one group of women 17 plus, and one group of boys 16. So there are three groups that we have in the data set. You can name your files however groups you want to test. And then you can say, here we have an indicator of how many times this row, what is the frequency of this row? 1002, 819, 606. So this is just a cross tabulation in a graph form. And this is telling us, even though there is a lot of information going on here, we don't see any particular departure for what we would expect following the chi-square distribution, as opposed to this distribution here, where we have girl 16, 917 contributions. Those girls were more associated with code 3 than what we would have expected following the chi-square distribution, and girl 16, 17, sorry, which are less in the sample, were less associated with code 3 than what we would have expected under a random chance. Very quickly, let's take a look here. There are extreme departures from what was observed and what was expected based on the cross tabulation. So overall, the entire data set, the entire table is significant. The red and blue are most extreme than what is expected. So if you needed to pinpoint where the significance of the p-value is coming from, or the chi-square, the significance is coming from the red and blue squares. Let's see. Very quickly over here. There you go. Here. So that is my interpretation of what code 1, 2, and 3 refers. So here we have code 1 refers to leaving school, start looking for a job, continuing with their training, either by starting a career or transitioning to college. That is the meaning of that latent code number 1. Number 2 refers to remembering or looking back at their past lives and retiring from their jobs. Code 3 refers to starting a family, having kids, getting married, moving into their first home. So let's take a look, 1, 2, and 3. Very quickly here, this we have code 1, more affiliated with men, according to the network depiction. A boy, 16, total number of relations, code 1. So let's see. That's what I remember. Code 1 refers. So if you wanted to classify this from a network analysis perspective and or a chi-square perspective, this is indicating that at least in this exercise that is imagining your life or whatnot, we still were able to find important associations of perspectives based on gender in this case. We are talking 1978. Once more, what is this, the implications and meanings of this exercise, that depends on your topic and research questions. And 2 and 3 that are more related to starting a family, and 2, remembering and being a little bit sad, even if you read the codes here, you will see it. 2 are more associated with being or being classified as a woman in that data set. Okay, one important thing that this is not capable of the information is somewhere there. There are some instances that participants clearly reflected some very depressed and suicidal thoughts that, even though they are part of the data set, they are obscured, they are not that prevalent or predominant. So we may lose those very nuanced understandings if we don't do a deeper qualitative analysis of the entirety of the data set. To the extent that you have time and effort and resources to do those analyses, I highly recommend that you strengthen your understanding based on that. All right, so let's see. Let's take a look at here what we have, the methodological implications of this. And perfect. Let's do it. Here we have overall, we're going to have 2 main matrices for the analysis to be computed. This, by all means, is not going to be a comprehensive review of the methods. But we're going to see 2 things. The first is that we're going to have 2 probabilities, and the 2 probabilities are going to come from the same set of data. One probability will be of detecting a word that we are calling WI, meaning a given word within the vocabulary that we have in our corpus. In our example, I think that our vocabulary was 200 words. One word as forming that vocabulary. What is the probability of that word being associated with the latent code or latent topic, ZI, that belongs to the topic ZI that belongs to the latent code J. So that is based on probability distributions. We're going to see how to calculate it. And then there is another probability that in this case is just going to be the probability that a given latent code belongs, latent code J equals our observed ZI in the data. ZI is a latent indicator of the code upon which the ith word was drawn, and renders this last notation, renders the probability that word I is assigned to code J. We're going to see, so the main challenge would be that this applies to a single text, but we have a collection of texts. We have a big data source with thousands of these options. So we have to find one way to expand this application to all the sentences and all the words configured in our data set. So here we're going to have the two matrices that are going to be the most relevant for our analysis. One will be the matrices of words W and topics J or codes J. The second will be the matrix of documents, not words, document. And this is where it starts getting confusing, because very quickly over here, this is how latent topic modeling is explained in the literature. So here we have files that are docs. In our explanation before, we have texts. For notation in topic modeling, you will find that texts are called documents. That is what is confusing: files, documents, and texts. So, but for us, what we are classifying is sentences and paragraphs, and we are uploading files. Does that make sense? Yeah. So that is, and I didn't change it because if you read it in the literature, you're going to read documents as opposed to text input. All right. So we have a matrix indicating documents and topics, and another words and topics. The dimensions will be, in this case, W will be the length of our vocabulary in the columns, which will be 200. And in our example right now will be 14. We're going to see how that actually appears. The dimensions of this other matrix and DJ will be how many documents or text inputs we have and how many codes we have. So that is the 2 by 2 matrix, where we have 50% chance, 38.5, 62.5% chance. So these are 2 by 2. All right. So let's apply these very dark concepts. We have two short texts. The same rationale, this is the beauty of data science, applies to thousands or millions of text inputs. The first is, my kids are home and I cannot focus. The second is, I wish I had kids. Being home alone is sad and I cannot focus. And I selected this text because they're conveying basically similar notions, right? But different, similar, but very different. So here we have, the first thing that we have to do is to replace these words with tokens, and the tokens are numbers. This is the tokenization process. So here we have only words. The process is as follows. Let's see. We have the same vocabulary, and we are not removing stop words nor nothing. My kids are home and I cannot focus, finished. If any of the second text input appears in the first text input, we don't duplicate that word as another column. We just continue the counting. So let's see, let's just put it in the same, because I get confused. Oh, actually we have it here. My kids are home and I cannot focus. My keys are common, I cannot focus. Ends here. Yes. Nope. Uh-huh. All right. Come on. Good. Very good. Finish here. Then I wish I had kids. I is already part of the first document. So we don't start with I. We just have tokenized I as one. I wish I had kids. Being home alone is sad. And already here. Cannot already here. Focus already there. So we don't duplicate those. And we find that the vocabulary length is 14. So what we can do then is we can write, this is basically what to data protection does. We can write those same information, those same sentences with numbers rather than with words. So we can rewrite them, and I'm showing them just as an example. So I will be 6, wish 9, etc., etc., etc. So we create, and we do that for any input that you have in your data file. Okay, so as I said before, we have to start with a good understanding of what a feasible topic number would be. This starts with a random process. So in this case, literally, we start by assigning topic number 2 to mine, topic number 2 to kids, topic number 1 to I, to R, etc., etc. Random topic allocation. This is quite bad because it's just the first iteration. The second iteration will change, will retain everything that we know from the prior, which is the MCMC, and then we'll exclude one word at a time and see, assuming that nothing else changed in this table, we're going to see how feasible is that the assignment of topic to mine will be a good, will render a good understanding of the distribution. So this is quite tedious to do it one by one. So at the end, we're going to have 2 probability values, and the probability values are going to be based on this information. So now we're going to rewrite this table. Let's rewrite this table over here into the 2 tables of interest. We have one table that is codes by words, and one table that is documents by topics, by codes. Remember those 2? So this is the input information that is going to help us rewrite those tables. So here we go. This is exactly what I just said. This is basically the Dirichlet distribution is basically a multinomial probability distribution, where, for example, one of the most, I guess, cool examples as a gamer is whenever you have a soccer player in a FIFA game, you have 3 strengths. You have speed, you have power, and you have ability. So you can take those 3 options as adding to 100. So you have to select, I want my player to be very fast, but if it is very fast, probably it's not going to be very powerful, and so on. So the multinomial probability is going to add always to 100. So taking into account, there you go. This allocation over here, we're going to, this is, as I said before, this is just the initial state. Mine is associated with number topic number 2. So in topic number 2, this is going to be the word where we have the columns is the vocabulary, and the rows is the number of topics. So we have the assignment over here, and basically we take that random allocation and place it there. So the sum of columns over here will indicate just a count of how many times a given word appeared in our collection of documents. So here, for example, I appeared 3 times. So it's a counting process. And we know that 2 times was associated with the topic number 2. So if we say, for example, focus, what we can conclude is that at the word to topic or code distribution, focus in the first iteration did a very poor job in helping us classify or gain understandings about topic 1 or topic 2, because it appeared twice in this case, and 50% appear in topic 1 and 50% in topic 2. So that is the probability distribution at the word level to topic level. So what we do is, assuming that all of this is true, humongous assumption, what happens if I say I'm going to decrease that value by 1? I'm going to assume that in this iteration, which could be the 479 iteration, I'm going to assume that focus is not part of topic 1, but everything else in here and in here is correct. How likely is that my structure of the relationship of focus with topic 1 is going to remain stable, or is going to fall apart? If it remains stable, that's part of the learning process. We can say, well, it should belong, based on the entirety of the distribution of the other words, it should belong to topic 1. If it falls apart, it is penalized and is moved to another topic. And we do this for each word across each cell of this learning process thousands of times. So that is the learning aspect of the algorithm. Then we have only one more that we already talked about, which is this one. This is the word to topic. And this will be the document or text input to topic. And here, at the end of the day, the 2 of them, if we do the counting, the 2 of them come from the same information, which is this information. So after each iteration, based on the evaluation of, by the way, we also decrease 1 value for each of these cells. It's less computationally expensive because in this case we have a 2x2 matrix, but we repeat. So you can, whenever you are doing iterations, we are doing changes to the 2 matrices, not only 1 matrix. And reassessing whether this table 3 should retain these values, these ascriptions that were randomly assigned at the end, or needed to be updated. The beauty of this process is as follows. When no information is learned, meaning whenever there is no changes in the structure of the data by removing 1 count of the word at a time, we are not going to overfit. The model will converge and there will not be more changes later on. That's why 5,000 is the recommended value to this learning process. If you want to do 10,000, it's going to be more time consuming in terms of running the models. Probably, likely, you are not going to gain any improvement in the classification process, unless your data is really a mess. Yeah. Okay. So we already talked about the 500 initial iterations, the burning period associated with that, and then the 5,000 times more iterations. So that is, in a nutshell, very, very superficial, so to speak. This is what the black box process is doing. It's a very tedious process. Thankfully, we have all these algorithms that do it for us. But very importantly, I think that, well, here we're going to talk about the topic assignment a little bit more in detail. We have 4 matrix. And then the dissimilarity, and those are the papers, and this is in the, there are very complex methodological papers where they basically made a case as to how to compute the dissimilarity between codes. Both of them use the same type of algorithms, well, very similar types of algorithms. The 2 of them are standardized to reach a dissimilarity value of 1. In these 2 approaches, the goal is that the comparison, whenever we run one iteration using n as the number of topics, we compare whether those topics are dissimilar or similar. To the extent that they are dissimilar is a good finding. To the extent that they are similar, that is not a good optimal solution to get clear understandings from these topics. In the second set of metrics, we have correlation values, Arun et al., Cow et al. Thankfully, they have been standardized into a single R package. So if you are interested in the documentation, I will show you in a little bit how it works. Yeah, overall, we have that's why we have 4 matrices, because it's going to run in each iteration, assuming that the optimal number is 2. In the second, the optimal number is 3, so that we can compare these similarities and dissimilarities 240 times in this case. So the Nikita and Chani package is LDA is the one that conducts these models. So no rule of thumb, we need to assess and analyze. We saw we have a 3 and a 7 solution. LACOID provides visual aids. The matrix and the Gibbs sampling use the same burning iterations as the final model that we are going to be testing or analyzing. Ideally, 4 measures should converge into a consistent result. In reality, whenever we have at least 2, we are happy. This is very, very messy. Nothing to do with LACOID. It is just topic modeling. LACOID just packages everything. So finally, let's talk about text preparation and mining. Here we have the standard the decomposition we already mentioned. Once we decompose these files, we apply text cleaning and mining procedures, meaning we remove well, it says non-English characters, but there are just these strange characters like breakpoints and non-typical accent marks, etc. And then we compute everything, we transform everything to lowercase. If we fail to do so, and we have learn with capital L, learn or lowercase, they are going to be considered 2 columns in the vocabulary as opposed to 1. Learn all capitals is the same. The stop words, probably I do have the list of the stop words here. Probably it's a little bit too small. Very important. If you are interested in adding your own stop words, you can add your own stop words. It just needs to be added to the source code. If you are particularly interested in specific stop words, I can change the source code for you. And I will show you the source code in a second. It's not pretty. But this is how this is computed. Now let me see. Good. What happened here? There you go. So we have about 108 stop words in English. If I'm not, no, 170 of 70 what? 2, 3, 4, 170. All right. So this is by default. LACOID does it in the background. And the other thing that was a decision that I made was to rely on normalization. I said that we normalize words. The normalization aspect is based on this approach called lemmatization. The lemmatization captures much richer vocabularies. So by preserving the meaningful form of a given document, here we have that we can preserve pronouns, verbs, noun, adjectives. And the stemming process is another normalization technique. However, it renders most of the time incomplete words. The example, if we happen to have a text input as follows: educational, educated, educate, education, educated, and we apply stemming, we're going to just preserve the root, and it will render or yield this result. Will be one single column in our matrix. If we apply lemmatization, we're going to have 1, 2, 3, 4, 5. Yeah, 5 different columns in our matrix. It could yield more sparsity in the matrix, more zeros, but I would believe that because we're going to remove the sparse terms as part of the text mining process, I still believe that lemmatization, even though it's more computationally demanding, it does yield richer and more complex vocabulary. If you are interested in stemming, I can also modify the code, or you can modify the code even better to the stemming. All right. Removing words, we already mentioned that there are some words as published by Shoot et al. That probably add little to the classification process. So we can definitely remove them if we are not interested in those words. All right. So voices retained. Oh yeah, let's take a look at this example. So we closed the methods section. I was telling George that 4 hours was not enough. He didn't believe me. All right. So we have the first example. The first example is as follows. Just for background, this is a project where we were inquiring how faculty members with volatile appointments, meaning that they have no security, were dealing with savings and retirement plans. So the example is as follows. The interviewer asks, in general, how worried are you about your ability to retire? I am not, the respondent. I mean, you know, like, I don't think I'm going to be able to retire. Or 2, I mean, I like a full disclosure. I don't think any of us are going to be able to retire. Any of us, meaning fellow employees under those same conditions. So if we don't do anything and upload this text to LACOID, in general, how worried are you about your ability to retire? 1, 2, 3, 4, 5, more than 10, right? It's going to be retained and it's going to be analyzed. It's going to be classified. Do we want to classify that information? Based on our research interests, we may. I wouldn't, so I decided to retire. The important question is, how can we preserve the information that comes from the interviewer? Very importantly, how can we preserve the information that comes from the interviewer to complement and make the information that comes from our participant to stand by itself, to be a complete thought? So in general, how worried are you about your ability to retire? I am not. If we just eliminate the question and start with I am not is going to be removed. It's a 3-word sentence. And I am not means nothing. In reality, at least my research team and I said, I am not worried about my ability to retire. The question for you all is, did we change the meaning of the participants' response? That is a debatable. The answer to that question is debatable. We didn't want to change the meaning of the voice of the participants. We just said, I'm going to complement it and to make it stand by itself. I am not worried, which is basically how worried are you about your ability to retire? I'm not worried about my ability to retire. Are we adding words to the mouths of the participants? We should not. We should be very careful about how to go about making these changes. These modifications allow the text to be uploaded to LACOID to be classified as a self-standing text input. The second example is, and how do you currently save for retirement in general? A different participant, etc. And then the response is, I have been my sort of retirement in that I've been saving, blah, blah, blah. So in this case, the modification only excludes the interviewer input. Based on our analysis of this answer, we concluded, me and my research team, that the information provided by the interviewer could just easily be removed and no extra information needed to be added to the response of the participant to make the text input a complete thought, a complete and self-standing thought. You may have a different opinion, that's completely fine. That's why we have to have consensus when doing this analysis, these decisions. And of course, we're dealing with interviewee, interviewee. The same sort of debate, conversation need to take place with whatever social media post, job posting, whatever type of analysis you want to conduct. In both modifications, the references to respondents, identification, or R, in this case, were also removed. LACOID is programmed to remove automatically words with 2 or less characters. So that is a decision I made. Probably I'm not, sometimes I think that I should not have made it. So if you have feedback, let me know. It's just literally 1 line of code to reverse that. These modifications require consensus, and we already talked about the document naming and testing. Do we have questions about this process? Overall, yeah, please. Well, it requires to prepare. If we have, for example, 40 interviews, it requires to remove the voices of the interviewers if we wanted to remove those voices. Yeah, that is, we're going to gain a lot of analytic power in the sense of the classification after preparing those tests. But yeah, it could be a tedious process. It wouldn't be as tedious as doing the coding manually, but it will require some work. I think that the loss of that approach wouldn't be that difficult or that important. Like, for example, if we decided to remove just the interviewer in this case, we're going to miss I am not. So that wouldn't be included in the text classification. So basically, very short sentences, if we are interested in sentence decomposition, will be removed. Based on how the interviews flow, based on my experience, these type of problems will be prevalent whenever the interviewee is actually reacting to the specific question at the beginning. So we will be losing the starting point of the answers. And if that is something that is worrisome, then we should do something about that. If not, recall that at any rate, you are going to have the data set with the removed sentences. So you can start your process exactly as you said, just remove the voices of them. And then you can say, probably this one. Yeah, you can see what am I losing by removing just the voices of the interviewers. So you can make decisions about that. And you can select what of these sentences you want to fix, if you want to fix them at all. Yeah. Good question, thank you. All right, so do we have questions about the renaming of files, or is it clear? It's good, very good. Let's see, this is just the metadata, hypothesis testing, we already have it. I guess that this is part of the whole conversation. This is an example by Saldana, 2013. Here, in a given response, we have a multitude of codes that help us with the classification of this text. The sentence by sentence decomposition aims to mirror this. Of course, it's a machine. We're going to fail sometime. We're going to classify meaningless information. That's why we have the threshold. That's why we have the evaluation of what are we dropping. But at the end of the day, those are tools to help us explain and be transparent in our analysis process, analytic process. Good. The trimming, yeah. So this is just application time. Let's see. Okay. Who was able to download LACOID? Good. Okay. Who was not able to download? Oh, so very quickly, in the handout, please, were you able to get a handout? Yep. So the data sets. Here you have the rich text format, which is the original one. Just if you want to, in your free time, if you have any, see, compare 1 or 2 or 10 files in the original format as they came with a modified version that I cleaned for LACOID. You will see that I was very careful in terms of not changing the meanings of participants' voices. So I'm providing the original rich text format as available from the internet, from this study, wonderful study, and the version that you have for LACOID. So in case you want to download the files to practice, just it's going to be a zip file as well. Good. You can download it from here, extract it, and then just let's start applying LACOID. So I'll be here in case you want to practice. Of course, you are more than welcome to use your own data sets, by all means. And I'm here. If you have questions, please let me know, and I walk to you and see how it goes. Good. We have time. Don't worry. Optimal number of? Correct. Yeah. So first of all, this is going to allow you to start the analysis process. In this case, we see that 2 of the metrics indicated that 3 is an optimal solution, but 2 of the metrics, other metrics indicate that it's not an optimal solution. So as I said in the presentation, when we have at least 2, we are in good stand to make the choice. However, in this particular case, we also have the 7 code solution. So the question then is, why 3 versus 7? Or why 3 versus 4? The reason why, well, first of all, running the 3 versus running the 7 is literally 2 clicks apart. You move this to a 7, or you move it to a 3 and execute, right? And then save the output, meaning these are all outputs. Save them, name them the 3 code solution, move it to a 7, execute, save the outputs with a 7 code solution, and then start looking at, that's how I would approach this. Then start looking at what is the distribution of these codes, the 3 code solution, and is there an overlap in these latent codes, or are they separate enough and in different quadrants so that I have at least eyeballing it a good initial understanding of what is going on here. How does this compare with the 7 code solution that we have here? Are we losing anything? Are we gaining anything? And this is just very visual. Here, what you can see is that code 6 is basically associated with everything else. And as you can see, well, like, team. So it's going to have, some of the words are going to be in other codes as well. So I would say, first, this graph. Second, this visualization, and start looking at your understandings. Third, and most importantly, the information that comes from these actual original texts. So on that, you can start by, I want to see the top 2 solutions. And what do I gain? And you actually have, this is a tedious process. You actually have to read the quotes associated with each, the most representative quotes associated with each topic, and start taking notes and start trying to see, does it actually make sense to explain coherently one latent topic? What about if I move to the next topic? Is there a lot of overlap in the meanings? And you will see that sometimes, for example, the reason I decided the 3 code solution versus the 4 code solution, these 7, 4, and 6 are going to be in the same quadrant, and they're going to be telling me basically the same thing. So the challenge is, I cannot tell what topic 4 is, or how is it actually very different from topic 7. And that is a problem. If you cannot tell them apart, you are not doing a good job classifying these texts. The same will be true with 2 and 1. They are in the same quadrant. They are not that close to one another, but they are part of the same latent space. 5 is doing a better job. It will be more associated with 6. 3, the same. So overall, this is not a bad solution. Whenever you see that in the whole context, it's not a bad solution. However, this is more efficient in the sense of you have lower number, higher separation. Just eyeballing them by themselves is not enough. You have to actually do the qualitative analysis. Yep. Parsimony, correct. Thank you. I was trying to remember that word. It's more parsimonious. And very important, parsimony should not be equated to aggregation, because you are basically, remember that it's the same matrices, the same input text, the same vocabulary, that is going to be aggregated in a 3-code solution as opposed to a 7-code solution. So parsimony and aggregation are not synonyms. If you are losing meaning by aggregating latent topics, that is a bad also classification approach. Meaning, if your 7-code solution, it still allows you to clearly tell a coherent story about what topic 4 and what topic 7 mean, and how are they different or similar for 5 and 1, go with it 7, because you're gaining more deeper understanding by having more codes. But there is no rule of thumb that says you have to select the most parsimonious, the least number of codes versus another feasible or optimal solution. Feasibility is the central word. There is a question? Please. Oh, it's, yeah, we have to typically rely on a 2-dimensional plane to represent this complexity. Ideally, it should be 3-dimensional or 4-dimensional, but as of now, the current state of, this is the state of the art depiction of these distributions, they are still 2-dimensional. It's just like a cardinal space. We have very much associated with cluster analysis, principal and component analysis. There is one latent component over here. This is another latent space. So we have 4 latent spaces. And what we do is try to accommodate as much as possible the information that is associated with the information that comes from these classifications. Recall that at the end, what we're having is, where is this? Where is my PDF? Here. What we're having is, to a great extent, this correlation over here. So to the extent that we have higher numbers here, we should have lower numbers in this row for us to be able to separate them as much as possible from one another. Even though this is a 2 by 14 matrix, we can just transpose it and it will be a 14 row by a 2-column matrix. And we can compute the correlations typically following the standard correlation approaches. But yeah, they're latent components. Yep.
Different types of text. So I'm curious.
Like what type of study? Sorry.
Case studies.
Oh, case studies. Okay,
So
cool.
you typically have like that are like at a higher discursive level, and then people experiences at
Correct.
so would you just run analysis separately? Like a policy document.
Well, if you combine them in the same analysis, because you are going to be decomposing them in sentences or paragraphs, you are still going to be preserving the origin of that document. And actually, you can actually test if you want to say, this is a policy brief, point 1. This is a policy brief, point 2. And then there is an individual interview, point 1, individual interview, point 2. And it's going to actually test for you whether the information containing policy briefs is more associated with certain topics than the information that comes from individual interviews. So that represents no problem whatsoever. If you are, and I'm giving this response because there is not a correct answer. If you are, however, interested in finding the voices of the participants individually and finding the voices of the policymakers and decision makers also separately, you have to separate them.
And then,
I think that I've been very much interested in that type of analysis to see whether or not the voices of participants based on policymakers versus interviewees are actually telling us different things. Yeah, and actually both analyses would be great, and I would love to see them. Thank you for that question. That's very important. So how were you able to run the models, or have you tried it? It's not okay. Are you a Mac user? Yeah, let's take a look. Yeah, Macs typically have a little bit of issues. Let's see. So does it give you an error message?
Yeah.
So let's see. Oh, cannot be opened because the developer cannot be verified. So what we have to do is, if you don't mind, let's go to preferences. And because this is based on freeware, it's not based on Mac software. So what you have to do is go here and in security, what is software security? Security and privacy. It's going to ask you if you want to open it anyway. It's totally fine. Then you have to, do you remember your password?
Thank you so
You're
much.
very welcome. If you have follow-up questions, please
Yes,
let me know.
I will be in touch because
Yeah.
no one's doing this right now.
Good, excellent.
University laptop. So
Yeah. So once you have this, it's totally safe. It's not based on any virus or whatnot. Sure.
So what about interview? What about just basic? Like if we have, for example, like essays.
Oh, actually, the analysis that we did for
Was
the
from essays.
it was essays. Yeah,
When I was asking you the open meta-analysis, it's because it's a methodology.
Illinois. Mhm.
Yeah, Illinois University. So
Oh, sorry.
I am wondering, I have been doing the ethnography analysis.
Wow.
And history.
And what does that mean? Because the meta-analysis typically is the review of published literature, and you get the
Yes.
coefficients, the standard errors. Is similar to that?
Meta-ethnography, the difference
Correct.
is meta-analysis is mixed methods,
Correct.
but meta-ethnography is just
Good.
so a meta-history is a kind of other analysis, but because I see the software that you have, I was wondering, but when you ask about this example, to have the policy analysis.
Correct.
Now I understand totally how we can use that. Basically, it's just the literature in one point. It's going to be the codes that you compare with the people that is, the essays of the students. You are using that as the data.
Correct.
Because the meta, you need to, I was wondering, what is the data? So the data is there, the secondary resources, dissertation of
Oh, wow.
people. So
Yeah, as long as it is text that you want to classify, LACOID will classify
and it's for
everything.
free.
Yeah.
Oh,
So
nice.
that is the software.
Yeah, that's and you did the development of the
Yeah.
software? Oh my gosh, you are.
Thank you.
I'm sorry.
No, that's fine. Yeah, that's why I had a.
You have this in Spanish?
It has been used in Spanish. Do you speak Spanish? Sí. Muy bien. Do you speak Spanish? No.
No, but
Yeah.
Right now I'm doing many of the historical documents are in Spanish because I am doing a meta-ethnography of
Wow.
the 1600s. So
Really?
yeah, the Mexico papers,
So
the
what?
state of Mexico are in Spanish, Puerto Rico are Spanish, Cuba is
Yeah. As long as the document is DOC, will be read. Can be analyzed. If you are interested in text file TXT, I can also provide you with an
I will
update
do
for
it,
that.
because what I do is I go to the library of the Congress, I download it, and
As a PDF or what?
as a PDF. PDF, but I have it converted.
Okay, because
So
I
from there,
already
I can convert it to
there is
PDF.
another software that reads PDFs that I
Oh.
designed. So yeah. So whichever is better for you.
I will say both.
Yeah, good.
I will say both.
Perfect.
Because I need to teach a class. Even though I'm still working my dissertation,
Correct.
For that specific parameter, the meta-ethnography,
Hmm.
meta-analysis. So what we don't have is the software.
Correct. Yeah,
For
there is
text.
no software. That's
Isn't, it's not. I was really,
the tools are there, but we have to learn how to program, how to code, computationally, statistically speaking, to be able to use it. So the software is actually just packaging all that code for us to implement it without the need to know how to program or code. Thank you. Yeah.
I
So,
will be writing you.
oh, please, yeah.
Admin Alvarez, I will be writing you.
Very good. My information is right, and I will put it.
I responded to your email request.
Oh, you did?
So yeah.
Yes, yes.
So I have your email
Good.
ID and everything.
Excellent.
I'm actually teaching a lot of mechanical concepts. So we have to do schools,
Mhm.
planning for classes,
Good.
TESOL, ELL, everything. So as part of the course, like we have to write essays about the reflection.
Exactly.
So I have like 60. I like to do like an analysis of what we have.
Very good.
Like 5, 6 years.
Wow, it's a lot of data.
Yeah. So yeah, I'm more interested in program chair for investment conference.
Mhm.
We have a conference in Cincinnati this year.
Oh, wow,
I
nice.
wanted to know if you would be interested in doing a session like this for us.
Oh, yeah, absolutely.
How much are you charging?
Well, in full transparency, I didn't charge anything for this.
Even they bill us.
Correct.
Wow.
That's how AERA works. So it is service. Yeah, yeah. Yeah, it is service. So the only thing that they provide is travel and lodging. Yeah, yeah. So I'm not. Don't worry about payment.
Then I'll contact you again.
Yeah, yeah, yeah.
For that.
Absolutely.
And I will do the same because I work for the American College of Surgeons.
Oh.
I work oversee many on the resident paper, and they are all over the world. I speak 3 languages, but no more than that.
Wow.
So he said, since you are telling me the program do not make a
Discriminate.
distinction
Yeah.
exactly between in what language.
I haven't
this is-
tried with Chinese though, but I have not. But it can be done.
because it's fun. I know.
Yes,
And Korean,
exactly.
we don't do that. Or for example, what about if it's from Africa? You know, we have the other Netherlands.
Mhm. We can try it. We can always try it because the tokenization part, it just identifies. Of course, the computer doesn't know that there are words. They are just repetitions. So it actually adds a number to each of them.
Gotcha.
So in theory, it should work. I haven't
should.
tried
Yeah.
with.
But I know why Chinese is different because
Correct.
it's symbols.
Correct.
And Koreans are symbols.
Yes.
And Japanese are symbols.
But this type of analysis is also applied to images. So in theory, it should recognize symbols, should recognize pictures. As the images will be matrices and the coloration of the. So for example, whenever people are doing biostatistical analysis of cancer tissue or whatnot, it's based on the coloration of the human tissue that allows classifying. So,
Oh my goodness.
so that's why they are comfortable with saying, well, you have 20% chance of having this type of illness or whatnot, because it's just a machine learning classification of big data that is running in the background. And they say it's better that we're wrong than it's better
That
than.
is exactly right.
Yeah, yeah, yeah.
So in the medical field, they use a lot of microcode.
Correct.
The papers are short. You cannot do more than that.
Yeah,
It's impossible.
exactly.
So,
And 20 authors. Right? Yeah.
yeah. So, and then what was the concept or the session that you were doing yesterday about it?
Oh, it's called, that is for machine-driven literature classification, which is classifying, very similar classifying
Can you
PDFs.
share with me
Yeah.
I will be
The presentation and the software.
I
as
am a
well.
very good self-learner, believe me.
Very good.
When
Yeah.
I read it and done,
Yeah.
I really got it.
Absolutely. It's very, very similar. And there is another, in case you're interested, that I have been working on, how to close open-ended responses, which typically, whenever you have thousands responses that you ask. Tell me another reason why you feel this way in a survey. You have to be able to classify those responses.
Yes.
So that software works with Excel spreadsheets rather than to
We can do a
PDFs.
survey monkey transfer.
Correct.
To
Yes.
the Excel.
Exactly.
And then the open-end question
And then you
will
apply
be
the
a
same.
column there. Oh, nice.
Exactly. Exactly the same rationale, classification, retrieval of the original text and whatnot.
So I will be confirmed.
Please. Yeah.
Remember, I know
Absolutely.
you have a very good memory.
I don't have a very good memory. I will
You do.
remember, yeah.
So
Great,
because
thank
in
you so
order to
much.
do this, you need to.
Yeah, thank you so much. I'll be walking to see if there is questions.
Absolutely.
Thank you. Any questions? Sure. That's fine.
No, actually, I was trying to.
Oh, okay, so this is a PC, right? Good.
Yes, PC, and I took wrong. I can't browse.
Yeah. Just let me make a little bit of announcement and I'll be back. So, all right. Just to close, I think that we need more time. However, I hope that this is not the end of the conversation. If you happen to have questions, want to brainstorm about the specific data input that you have, please, this is my contact information. I develop these softwares to be used, not for me to just have. And as I said before, this is open source, free to use, free to distribute. And so just, I know that we are a little bit off time. Let me just show you very quickly, in case you are interested in modifying the source code, in case we have some programmers in the house. Here we have, well, depending on what you have, I'm using a Mac, a PC now, but it's exactly the same as in Mac. And actually, I show some of you how to access the application file. So on the resources in your app, and this is true also for Mac, you will have an app.r file. The app.r is going to compile all the information. So this is basically how the first part is the user interface aspect of this. You don't have to make sense of it. The second part is the actual analysis, statistical analysis of all. This is the cleaning part aspect, etc., etc. So you can play with it. If you modified, just reload the file that you modified, you wouldn't lose anything. Please, let's keep the conversation if you're interested. All right, thank you.